Okay, guys. Really, we're more or less at the end of the space part of the module, but I thought it's probably a good time to have a quick look back at where we've sort of come from in looking at exploring space, but also where we're going to be going in the future. And there's some questions here that if you can answer those by the end of it, then you're doing all right. So I'll put those questions also on Insights. You can have a quick look at them. But let's see how many of those you can answer. And if you can talk about the main advantages and disadvantages of manned and unmanned space exploration by the end of it, then we're probably doing all right. So, let's make up for the sort of the early space pioneers, really. Space exploration really came about primarily after World War II with big advances in rocket engineering. Actually largely due to the Nazis, because they were really big in producing very successful rockets during World War II, and the Cold War that then followed. So the Soviet Union and the United States were in a very ideological war based on their differing political beliefs, and as a result of that they wanted to show their dominance from a technological point of view, so there was the space race. And both sides, the East and the West, were desperate to get people into space as soon as possible. And both sides really were putting animals in space from a very, very early point. Even sort of the late 1940s, various animals from fruit flies all the way up to sort of chimpanzees were being launched into space in rockets and then sort of gently parachuted back down to Earth, or in some cases when those parachutes failed, with a much larger crash. And the sort of two real milestones here is this dog here called Laika. Laika was the first animal ever to orbit the Earth. So Laika was put into orbit in 1951, just to show it, just to sort of really test the technology to see if we could put people into outer space. And so Laika was launched by the Russians into Earth orbit and died in orbit. Actually, she wasn't brought down again because the technology wasn't available to do so. But that was in 1951. By 1961, the technology had been developed to the extent that Yuri Gagarin, that's him here, was managed to be launched into Earth orbit in 1961, and he completed a successful orbit of the Earth and then was brought home safely. So, big step forward there. The next big milestone, having gone from the first man in space, it was then the first man to set foot anywhere else in our universe. And so in 1969, Apollo 11 mission was launched with Neil Armstrong and Buzz Aldrin and Michael Collins, who was the pilot. They launched from Kennedy Space Center in Florida in July 16th in 1969. It took them 3 and a bit days to fly to the moon in a Saturn V rocket, and Neil Armstrong and Buzz Aldrin went into the landing module called Eagle, and on July the 20th they landed on the moon, Neil Armstrong being the first man to set foot on the moon. It's difficult to sort of overstress how significant an achievement this was for the human race. This was the most widely watched television episode ever. My parents watched this in a little guest house in Portree in Scotland whilst they were on holiday. It's a really significant sort of event. Anyone who had access to a telly would have watched this, and they watched Man on the Moon live. So that was the first sort of setting foot on a different celestial body that's not planet Earth. From there, other significant endeavours are the Voyager missions. Now, Voyager 1 and 2 were launched in 1977. Their mission was to go to Jupiter, Saturn, Uranus and Neptune and study these gas giants sort of that are huge distances away from Earth. Subsequently, they continued outwards from our solar system. So Voyager 2 went on to Uranus and then to Neptune, and now both of the Voyagers are tasked with exploring interstellar space. In 2012, data from Voyager 1 indicated it would become the first human-made object to enter interstellar space. Now, it's not the first thing to have left our solar system. Radio waves from the 1940s were powerful enough by that point to be transmitted far enough into space that we've actually sent radio signals into outer space. So we have sort of made our mark. They will take a very long time at the speed of light to start reaching other planets that could potentially sustain life, because nothing we can observe in our observable galaxy is capable of sustaining life. But we are sending messages out there. So that's Voyager, and the Voyager probes are still travelling out there at a speed of 17 kilometres per second. It's phenomenally fast. And it'll take them about 40,000 years to meet anything outside of our solar system. Right, moving on from that, the next big achievement was the Rosetta mission. Now, that was launched in 2004, and it was on a 10-year mission to intercept a comet. So we could study comets in some detail, which is an incredible achievement when you think about it, because comets move very, very fast, and to land a probe on a comet is incredible. So it arrived on Comet 67P, and it managed to put a lander down called the Philae lander, which then was able to take quite significant measurements. So it's an incredible achievement being able to shove a probe on a comet. But what did it discover? Well, it actually made some really exciting discoveries about our origins on Earth, because some of the things that were discovered in the sort of almost the gas cloud around the comet, the evaporating gases coming off, phosphorus was discovered, and very simple organic molecules, simple amino acids. And why that's potentially exciting is that amino acids they assemble into proteins. Proteins then can assemble into DNA. We believe that the comets may have seeded our planet by dumping very useful molecules on there that then gave us the origins of life. It was also discovered, and this is quite an interesting discovery, that it contained a lot more deuterium. The water on the comet, on comets are dirty snowballs in space, big lumps of ice and dust. The water on the comets contains a lot more deuterium, or heavy hydrogen, than water on Earth. And that's really useful to know, because we believe water on Earth is extraterrestrial in origin. There's a lot of theories about that. And we believed it may have come from comets. But having analysed water on a comet, it may well be that that's not where that water comes from. It doesn't mean that asteroids potentially didn't bring water to Earth. That's still a plausible theory, but the comets appear not to be the source of water on Earth. So, where are we going next? Well, NASA has put has made a suggestion that they will be aiming to put man on Mars by 2030. There will be a manned mission to Mars by 2030, and they are launching more and more probes to support that at the moment. So, how's flying to Mars going to be difficult then? Well, the journey is about 9 months. It takes about 9 months to fly to Mars, and that's a bit longer than currently astronauts stay at the International Space Station. There are people who have done longer. The record is over a year, but most people stay on for about 9 months. And that's a really significant problem in terms of logistics, putting man on Mars, because you're going to have to provide food for the crew for 9 months there, and also 9 months back, because we don't want to leave them there. We do want to be able to bring them back again, and that's one of the big sort of the big problems associated with interstellar flight, or particularly exploring our solar system, is getting people back again. So we need to make sure they've got food, we need to make sure they've got water. You need to have a sufficient oxygen for the crew to be able to breathe for 9 months, or a method of producing enough oxygen, maybe with photosynthesis. They will also need fitness equipment. There's a huge amount of muscle wasting that goes on in space because there's no gravity, so you need to give them adequate fitness equipment so they can maintain bone density and muscle mass. Otherwise, when they come back to Earth, the long-term effects of that will be really quite damaging. What else do the astronauts need? Well, they're going to need mental stimulation. They're going to need 9 months worth of things to do and things to combat homesickness. It's a very long way to go, and it's a very dangerous journey, and that's going to be quite a difficult thing to sort of manage as well. So long-term trips are problematic. There's also the problem of the huge amounts of interstellar radiation. We get loads of radiation from the sun. Our atmosphere does a fairly good job of blocking it out. There are lots of cosmic rays that effectively are blocked by our magnetic field as well. So that protects life on Earth. When you go outside of the Earth's protective bubble, then there's all sorts of problems for astronauts in terms of the radiation they would be bombarded with, as well as all the other issues of just keeping them fed and watered and healthy. So, what can we do? Well, what we're looking for in the future is looking for potential sources of life outside of our planet. Our planet is a finite resource, so we need to sort of to ensure that the survival of our species find somewhere else just in case. So we live in the Goldilocks zone in our solar system. Why is it called the Goldilocks zone? Because it's not too hot, it's not too cold, it's just right. The temperature on Earth is a good temperature because water is a liquid. If we go to the moon and we didn't have protective equipment, you boil in the daytime, you freeze at night time. That's not particularly helpful. So we want a rocky planet, a terrestrial planet. We want something that's reasonably Earth-sized because we want the gravity to be very similar. We want it to have enough be massive enough, have enough gravity to hold an atmosphere to it, even if it's not a breathable atmosphere, just to give some insulation. We don't want to be on a gas giant because there's no solid surface, and it wants to be in the Goldilocks bit. Not too hot, not too cold, just right. So, this is what I want you guys to do. Okay, I want you to think about the advantages and disadvantages of manned versus unmanned spaceflight. So, very, very briefly, right, I want you to look at these statements here and decide whether they're manned or unmanned sort of advantages. So, here we go. There are many high risks because there are many failures that can occur, especially when experimenting on new systems. We only put Leica in space to see if they would survive, if the dog would survive. We didn't think about bringing it back. Takes away the risks imposed on astronauts. Obviously, requiring long life support, these extremely complex systems need to be installed into spacecraft. Do not require life support. The cost of missions is much higher per mission. You can explore more places for the same amount of money. These missions are restricted in the places they can go because of physical boundaries. You don't have to be brought back, making missions only half the work, if not less. You can go to extreme places, and humans need to be brought back alive after the mission has been completed. This adds complex systems to the spacecraft. So I want you to put those into manned versus unmanned. Separate those statements into manned and unmanned, and think about whether they are advantages or disadvantages. So that's us. Okay, hopefully you've had a go answering those questions. Let's see how we got on. So what was the name of the rocket that first put man on the moon? That was the Apollo 11. How long did it take to get there? Approximately 3 days. So what is Voyager and where is it now? Well, there's a pair of Voyagers actually. They're space probes, and it's now left our solar system. It's now in interstellar space. What was the unmanned probe sent to land on a comet? So why was an unmanned probe sent to land on a comet in the Rosetta mission? A, because it's phenomenally dangerous. B, because you don't have to bring it back. There are people on there, whilst they would have been much better at problem solving, because humans are very adaptable compared to a computer system. Obviously, you'd have to bring it back again. How long it takes to fly to Mars? Depends on where Mars is. Bear in mind that we're all moving around the solar system, but on average, somewhere between 7 to 9 months. And what will the astronauts need for the journey? Basically, life support, food, water, physical equipment, mental health sort of equipment. And then I want you to be able to list the main advantages and disadvantages of manned and unmanned space exploration. Okay, hopefully you've managed to do all that. Best of luck, guys, and I'll see you all soon.